Moving on to LIS, short for list embedding, which is a dynamic functional first byte compiled language embedded in Pharo. LIS pushes MOGs and ASL to their limits by exploring the ambiguity, conflicts, and interplay of multi-paradigm, functional, object-oriented, and procedural language design. LIS raison d'etre is to help you study the wizard book with a Xerox flavor while reinventing some Bell Labs utilities. Here is the extended version of the postcard we saw earlier, this time written entirely in LIS. Right from this first example, we can see some interesting semantics that are made possible from the compiled embedding of a Lisp dialect into an object-oriented environment. Like the smiley alternative to parenthesize function calls that serves both for scoping LIS syntax from within Pharo and for scoping Pharo from within LIS. In this example, the return caret is part of a Pharo statement, while the rest of the method from begin till the end is a LIS expression. Scoping Pharo syntax from within LIS can be seen in the copy from message right here. This kind of scoping can accommodate other kind of syntaxes as well, and I'm currently investigating cases where it can be implicitly inferred at compile or even runtime. Moreover, since LIS is embedded inside an object-oriented language, there is no reason to restrict ourselves only to lambdas as heads of functional invocations. In fact, in LIS, every entity responding to the LIS-specific polyvalue with arguments message can be used as a functional application head. This includes lambdas, which is how normal function invocation works, symbols, which accept an object to be applied to as a second argument, but also every other Pharo object, since a default polyvalue with arguments message is defined in the hierarchy root, accepting a symbol to perform as a second argument. This unique interplay between the two paradigms also produces interesting, truly emergent syntactic and semantic forms when we consider the use of primary values that are being shared. Let us check this mixed unit test, for example, where assert and equal messages are normal Pharo expressions, while the rest of the method is written in LIS functional style with scoped Pharo embeddings. Observe closely the use of Pharo blocks and dynamic arrays seen here on line 2. There is no smiley scoping here, yet we can mix Pharo code with a functional LIS invocation. The block is at the head of the expression and will thus be evaluated with a dynamic array as its argument. This non-scoped embedding emerges automatically in an environment where object-oriented expressions and functional expressions share the same primary values. As a side note, you might have noticed that the +LIS function here is variadic. This is still another LIS extension since Pharo does not natively support variadic lambdas. Primary value sharing is beautifully expressed in the LIS recognizer and compiler, which are assembled through grammar traits. The LIS expressions recognizer by itself operates only over lambdas, lists, numbers, and strings. The above composition says that the resulting sum of the extended Pharo grammar with LIS expressions should use the full set of Pharo primary values instead. For the extended LIS compiler, the composition is even simpler, since any conflicts or overrides were successfully handled at the recognizer level. As a first step towards porting larger functional programs, I have implemented Norvik's test suite for Lisp implementations in LIS. Notice here the mixing of LIS expressions with a custom Pharo operator used as a shorthand for assert equals to unit test LIS expressions. Now for the punchline. As we noted earlier, smiley scoping can be used to accommodate other syntactic extensions as well. So here is a LIS postcard mixed with the imperative extensions we discussed in the grammar traits overview. With the exception of the pragma here in the beginning, there is not a single Pharo expression in this method, only functional and procedural extensions. Finally, here is the postcard with all three paradigms combined: functional, object-oriented, and procedural imperative. This last example shows us what is possible with Mogg's, Gray, and grammar traits, probing both emergent semantics and how far we can go with cross-paradigm composition.